the two things we're adding today on the peach packet are something called behavior. We talked about in behavior, and that's specifically what's happening at the ends of each graph. So the behavior of the function is what's happening in the middle. So there's three options, and we always read a graph for behavior from left to right, just like you read a book. So we're starting from the very left and working our way right. And so there are three options that it could be doing. It could be increasing, so it's rising. There's a positive slope, like I said, we're looking from left to right. It could be decreasing or falling, so it's going down as you're looking from left to right. And then we do have an occasional times where the graph goes constant or flat. So actually, I'll take this off so we can better. So there's three options: increasing, decreasing, or constant. So like I said, we always read it from left to right. And we're going to use interval notation to show this. And it's always x values. So usually we start from negative infinity because we start from all the way left and work ourselves all the way right. So we're going to end with positive infinity. And so then the graph will change just depending on what our graph looks like. So you have always from left to right, and we have our three options. Typically with our function graphs, for the most part, we just use the two, increasing and decreasing. So for the most part, it's just rising or falling. But there are a couple of graphs where we'll have a constant. It has to be straight flat when you see that. So let's look down at the examples. So with our graphs, typically, unless you see specific points, like I've been saying, assume that there are arrows. So I'm actually going to go ahead and put arrows on these. So with this, and like I said, I already kind of said this before. So we're going to do intervals of increasing and decreasing. So we're going to do our interval notation. And we're just going to use parentheses with this.
Good morning. Just a reminder, if you are in strength training, you have that on Monday, Wednesday, Friday. If you have PE, that is on Tuesday and Thursday. So if you're a PE student, you need to go to study hall today. That will be in the media center. Thank you.
So when we're doing our intervals of increasing and decreasing, like so we're going to use interval notation. We're just going to worry about parentheses. We don't really use brackets for this, so just parentheses. And like we typically start from negative infinity, and then work ourselves to positive infinity. And we're looking at the x-axis. So I know that can get a little bit weird because our graph is going up and down and different things, but we're looking at the x-axis because our graph is traveling from left to right. So that's why we use x intervals. So we're going to start at the very left part of the graph, and then we're going to start following our graph. So is this going up, down, or is it level? Oh, it's going up. So as we're looking from left to right, it's going up. So we're saying that it's increasing. Okay, and that's from the start of the graph. So we're going to say from negative infinity. Now if it increases for the entire time, we can actually say it's increasing from negative infinity to positive infinity. But as we're going, it's going up. Does it ever stop going up? Yeah, right here at -2. So it's increasing from negative infinity to -2. And then our next interval is going to start at that same point. Because at -2, what does it start doing?
Decreasing.
Decreasing. So we're going to say decreasing. And again, that's why we use parentheses, because the intervals start and stop at the same spot. So where this stopped increasing, it started decreasing. Now does it decrease for the rest of the time? No. Okay, so it's going to decrease to right about here. And this where it gets challenging because we're going to use this x value. So it's very tempting to say -4. What's the x value there? 0. Yep. So it's decreasing from -2 to 0. And then what does it do from 0? Increases again. Now there's two ways you can do it. You can write increasing in and write the other interval. But since I've already written increasing, what I can do is just next to that other interval of increasing, just put my next interval of increasing. So from 0, and then does it stop increasing?
No.
No, so it's going to increase for the rest of the time. So since it's going to continue going up, we're going to say it's from 0 to infinity, and those are my intervals of increasing and decreasing. So there's no constant with this one, because there's no places where it was definitely flat. This one, and like I said, this is what I typically do. I just make a list. So it's increasing in these two spots on the graph, and it's decreasing in this one spot. Questions about the first one? it doing right away?
Decrease.
Decreasing. And like I said, the nice thing about this is it was one thing that remains consistent. You always start from negative infinity and you end at positive infinity. So it's decreasing to start with. So from negative infinity until about where? What do you want to say that x value is?
3.
3? Okay, just 3. Negative 3. Yep.
Oh,
So again, decreases from negative infinity again to about negative 3, because again we're looking at the x-axis. Then what does it do? Increases. Again, it starts increasing where it stopped decreasing. Does it increase for the rest of the time? No. Where does it stop increasing? 0. Yeah. So you can do rough estimates. Okay. Technically, it might be a little bit before that, but we can say 0. Then what does it do? Decreases, which I ran myself out of space. Just gonna write it above it. 0 to where does it stop decreasing?
2.
About 2. And then what does it do from 2 on?
Increase.
Increases. And does it stop increasing?
Nope.
So that one had 4 different intervals. So there's 4 different times to change slope within that graph. Press up first, too. Okay, next one. Now we're gonna look at some those two are the more common ones that we'll see because it switches a couple of different times. Sometimes though it may not switch, and there are sometimes, like I said, there's a third option that we don't see very often, but we can see it. So that's what we're gonna cover in the next one. So this first one. Again, we go to the very left end. Okay, what's it doing?
Increasing.
It's increasing. Okay, so it's going to increase. It's never going to stop increasing. Okay, with this one, this is where it gets a little tricky. So it's kind of stops increasing here, but it doesn't actually, it's just for 1 point. Because if you look, it's a little bit below here, a little bit above here on the next one. So this is actually not a constant because it's just for this 1 point. So it's just changing slope and becoming a little bit more flat. But does it ever, this graph actually never stops increasing. So like I said, it changes slope a little bit there in the middle, but it's only for that 1 point. So it never goes, in order for it to be constant, it has to be for a chunk of the graph. If it's just for 1 point, then we say it's still kind of increasing there. So this graph is actually increasing the entire time. So we can have that happen. So we're gonna say it's increasing, and you can abbreviate from negative infinity to positive infinity. So in order for it to switch back and forth, it has to have a definite turn and be for more than 1 point on the graph. Does that make sense? So that one's always increasing. This one we have a new one. So here, if we go to the very left end, what's happening here? It's constant. So this is the time where if it's flat, again, for more than 1 point, it's flat for several points. And we're going to say that's that new one that we haven't had on our example yet. Okay. So it's constant from negative infinity until what x value?
-1.
Negative 1. So then it jumps down here. And again, if there's a jump or there's a gap, that's fine. So it's constant here, then our graph jumps, so our intervals are going to jump. So then at -1, what is it doing down here?
Decreasing.
Decreasing. And we got a couple points down in there, and then does it decrease for the rest of the time?
No.
No, where does it stop decreasing?
0.
0. And then what does it do? Increase. Does it stop increasing?
No.
So there is the middle behavior of the graph. Again, we read it from left to right. Always start from negative infinity, always end at positive infinity, and you're looking at x values. That's just about that part. Excuse me. So that's one part. The next one these together is because where the graph turns, what it does is it creates an extrema, which is a new word we're going to talk about. So what an extrema means is when your graph switches from either decreasing to increasing, so it changes direction. It doesn't, extrema doesn't include if it switches from constant to something else. It only covers the two possibilities, either switching from decreasing to increasing, or from our other graphs, increasing to decreasing. So those create extremas, or the extreme values of the graph. And so those are minimums and maximums. And there's actually two different types. That's what I have next. So if they're called critical points of the graph, so they're extreme points. So like I said, where it changes from either increasing to decreasing or decreasing to increasing creates some type of maximum or minimum. Okay. So whenever the graph turns, that's where the extrema happens. So there are two different types of each. So there are something called a local minimum or maximum and an absolute maximum. So if it's a local maximum, that means the graph is increasing and it turns and then starts decreasing. So it kind of creates like a mountain shape. And we use that word a little bit with our parabolas. But the big difference with our parabolas is it only had one turn. This one, our graphs now have several turns. So it's a local maximum if it turns from increasing to decreasing, but it's not the highest the graph goes. So it's just that maximum in that local area. It's that one part of the graph, so that one little interval. So that's called a local maximum. The other type of maximum is just, it's a maximum over the entire graph. So it is the highest the graph goes, so then we call that an absolute maximum. So those are the difference between local and absolute. So local is just over that part of the graph, but there's other parts of the graph that are higher than it. If it is the highest the graph goes, we call that an absolute max. So those are the two different maximums. And then minimums work the same way. The way we get minimum is if your graph is decreasing and it switches to increasing, so it kind of makes that valley shape. Again, we've used that word before with our parabolas, but now, like I said, we have more turns in our graph. So we have two different types of minimums and maximums. So again, local minimum, it's that the lowest point over that part of the graph. So just that interval, not necessarily the lowest the graph goes. And if it is the lowest the graph goes, we call that an absolute. So this, what you're going to need is one of those classifications. So local max, local min, absolute min, and then you're going to list the point that it happens at. So you're going to have the x and y where that occurs. Any questions on the terms? Okay. Now with my examples, and honestly, the graphs I pulled from the book, I just had an equation and I went to Desmos, and you don't have to snip these, but for me, I just pulled it out from Desmos because all I had was an equation. And that's how your assignment's going to be. You're going to be given an equation, and just you have to go to Desmos to look at the graph. I'm not worried about snips, so you don't have to worry about snipping it, but you will have to use your graphic calculator to see the graphs. So this graph turns several times. So we have a turn here. So I highlighted that. We have a turn here, and then we have another turn here, and up here. So there's 4 different turns. So that means we have 4 different extrema. Oh, the other thing I forgot to say is you can have multiple of each type. So you can have 2 local minimums, you can have 2 absolute minimums, you can have one of each, you can have all different combinations, but you can have 2 of one type. So this one, the graph's decreasing, and then hits this point and turns and starts increasing. So if your graph is decreasing and then it turns and increases, that creates a minimum. Okay? So I know that this point is a minimum. Is it the lowest the graph ever goes? No, because there's other parts of the graph that are lower than it. So since it's the not the lowest the graph goes, what type of minimum is it? Remember our words? Local. Local. Yep. So it is local. So we're gonna say that's a local minimum. I don't think there's a good way to abbreviate local, but you can abbreviate minimum and maximum. And so then you're going to list the points there. So we're going to say that's a local minimum at -1 point. You don't have to list all the values. Either -1.2 and -4.3. So there's one of our extrema. So it's local because it's not the lowest the graph goes. It's a minimum because our graph was decreasing and then it switched to increasing. So now we follow our graph along, so now it's increasing, and then hits this point, and then it turns for just a little bit, but it does turn. So that creates another extrema. So since it's increasing, and then it turns and decreases for a little bit, that is a maximum. And is that the highest the graph goes? No. So what it is? What type of maximum? Local. Yep. So it's a local because it's not the highest the graph goes. It's a maximum because it switches from increasing to decreasing. And that's right at 0, 0. So it decreases for a little bit and then turns again. So what type of extremas are 0.6 and negative 0.6? Is it a minimum or maximum? Minimum. And is it local or absolute? Local, yeah, because there's still other parts of the graph that are lower than it. I'm going to list it the second time, but you could, just like with our increasing and decreasing, if we already had local min and I had space, I might just list it with the other local min points. But since I don't have space, I'll list it a second time. And that's at 0.7 and negative 0.6. And then the next one, our graph's increasing, hits this point, turns and starts decreasing again, so we have another extrema. So is this a minimum or maximum? Maximum, and is it local or absolute? It's actually local. Okay. So it does look like it's highest graph. So any parts of the red line that are higher than it, which this one is, this little part over here, is higher than that, so that is still considered a local maximum. So in this graph, all we had were local mins and maxes. That can happen. That actually happens quite a bit. Especially if your graph's going off in the directions forever in either direction. So we had a graph, part of the graph was going up forever, part of the graph was going down forever, so all the minimums and maximums were going to be local if that happens. And like I said, I listed all 4 of them out separately, but like I said, if you had listed local min and had space, if you just write 2 points behind local min, that's fine. Same thing for local max. Questions about the first one? Next one. This graph turns 3 times. So this graph is going up, and then hits this point, turns, goes back down. So this is this a minimum or maximum? Maximum. Is it local or absolute?
Local.
Local. Yep, because there is part of the graph that's higher than it. We have a local max at negative 1.5 and 2.1. So our graph turns, it goes down, hits this point, it turns, starts going back up. So is this point a minimum or maximum? Minimum. Is it local or absolute? Local. Yep. So there is a part of the graph that is lower than it. As long as there's that blue line that's lower than it, so it is a local min at negative 0.3 and negative 0.3. Then we have one more turn. Is it a minimum or maximum? Max, is it local or absolute?
Absolute.
Absolute. That is the absolute highest that graph goes, so it gets an absolute classification. And it is a max. We got 1.1 and 3.1. Questions about that one? So the first one we had several that was the same. Okay, we had 2 of each. Okay, this one, all 3 of them were different types. You could also have 2 absolutes. So like if this one had gone up just a little bit higher and had been level with this other maximum, it's actually possible to have 2 absolutes of something. You have 2 absolute maxes or 2 absolute minimums. You can actually have more than 2, depending on how crazy turning your graph gets. So how many turns you have is how many extremes you have. So this one had 3 turns, so 3 extrema. So we listed the types and the points with each one. And then I have a couple other examples we're going to go through really quick, just to give you some more unique things. Okay, my first example and my third example are pretty much the same. I just now realized that. This one one's pretty close to the first one. Sorry about that. There's going to be 2 local minimums and 2 local maximums. So I'll just write these down real quick just because I have it on sheets, but I should have changed that and give you a little bit more variety. Sorry about that. Okay, so we have 2 maximums here and here. Both of them are local because there's green parts of the graph that are higher than that. So I'm going to write local max and list both of them. Sorry. Oh, let's just say -1. That's fine. -1 and then 2.02. And then there's another local max right here at 0.7 and 0.5. Like I said, I'm going through this one kind of fast, but it's very similar to my first one. And this one has a local min. There's 2 of them, so I'm going to just list. So our local min here again at 0, 0 turns from decreasing to increasing. So that's the minimum. There's other parts of the graph that are lower than it. So 0, 0 is a local minimum on that one. This one's also a local minimum. Because again, as long as there's green parts of the graph or whatever color the graph is, higher or lower than it, it's considered local. So there's another local min, which I can local min again, at 1.9 and -4.2. So there's that one. Like I said, that one's really close to the first one I did. I wrote it a little bit differently because I saw it and I gave myself space. So again, you don't want to write local max 4 times or 2 times. You can just both points under the local max and find that. Okay. Last one. Sometimes you get graphs like this that are kind of boring. Okay, there's not a lot going on. In order for us to have a minimum or maximum, your graph has to distinctly turn. So it has to definitely turn from either increasing to decreasing or decreasing to increasing. So this graph ever turn? No. So you notice it's a nice, not quite straight line, but it's a nice line that's going up forever. So this graph never turns. So it's possible to have no extrema. So if that ever happens, if your graph never distinctly turns direction, so either from increasing to decreasing, decreasing to increasing, then what we say is there are no extremes.